Hi, welcome. This video is going to talk about two-dimensional arrays in Java. So what we've done so far in Java is we've looked at single-dimensional arrays, where we have really just one coordinate. So if I want the contents in an array of position 0, I could just say, give me the contents of array at position 0, or give me the array, or the contents of array at position 1. So down here, for example, if I wanted to print out the string that was stored in position 0, I'd say, give me whatever's in position 0. Similarly, if I wanted to see whatever's in position 1, I could just put in a 1 here. Now this is a very handy, very powerful concept because we can store any kind of object inside of an array. So we could put in car objects, we could put in cards, right? It's a very classic way to build a deck of cards, right? Where you have an array of 52, where each element is actually a card object. There's many other things. I mean, you can store anything in an array. So it's really nice to have a way of a container to hold things. Now, in the world around us, sometimes we need the concept of two-dimensional arrays. So the ability to store things in more than just one dimension. We can get a little more power out of the information that way. So let me show you what I mean. Just copy this here. So if we had a three-dimensional, sorry, it's a single-dimensional array with 3 elements. Now what would happen is if in position 0 I said, well, the contents of position 0 are a three-dimensional array. So now I have in an array position another array. And I did the same thing for position 1, and the same thing again for position 2. So in each position of my first array, I have another array. And then I could actually address these. I could say, my 2D array at position, this would be position 0, 0. So just like before, I'm in, my first array is position 0, right? And row 0, and then my column is also 0, right? Because we start counting from 0 this way. So similarly, this would be position 0, 1. And this one here would be position 0, 2. And now I'd be into row 1, column 0, right? And this would be row 1, column 1. And you can see the pattern that's developing here. So this gives us actually tremendous ability to model things that are natural in the real world beyond what we would normally see in a single-dimensional array. So let's take a look at building one of these in Java. So if I go into to Java, I have a little bit of program pre-built here already, but let's take a look at how we typically have stored single-dimensional arrays. So we've always started off with our data type, which is, in this case, it's going to be integer. You could have any other data type, strings or car objects or whatever you like. And we put the little square brackets after to denote that it's an array. That's how we're telling Java this is an array. In this case, I gave it a name. Well, in all cases, you give it a name. So here's my data type. In this case, it's an integer array. Its name is single dimension. And then I gave it some initial values, 3, 4, 5, 6. And if I put a little comment up here, this is position 0, position 1, position 2, and position 3. So if I want to access any of those, I could say single dimension at position 0, right? So I could say system.out and what it would do is it would first look at the name of our variable, which is single dimension, and then it's going to look in position 0. And in position 0, we have a 3. So it would print the number 3 to the screen. Now, we have other options, though. we could define a single dimensional array this way, where we say, well, my data type is an integer array. I give it a name, and then rather than initialize it to some value, I could actually just say it's going to be a new integer array and there should be 4 positions in it. And then I could individually set each of those positions. So at position 0 I want a 3, at position 1 I want a 4, right? And that would actually create an array with the same contents as this array. So very simple, very powerful concept. If we want to do a 2-dimensional array, well, really what we're doing is we're defining an integer array, and we're saying in each array position we're going to put in another array. So let's call this one 2 dimensions, and I'm going to define it by saying it's a new integer array with 3 rows and 4 columns. Okay. And if you're used to Cartesian coordinates, right? So if we go to good old Google here, and Cartesian. So let's take a look at Cartesian coordinates. Good old Wikipedia. So the idea here is that we have an x value and a y value. Now in pure Cartesian coordinates, this would be positive, and everything down here would be negative. In the coordinate system we're going to use, it's going to go positive this way and positive this way. Okay, so we're going to create a 3x4 grid, and what I've done is I've created 2 for loops. The first for loop is going to represent our rows, and what it does is it says go to my 2 dimensions array. Okay, so here's 2 dimensions, and give me the length of the array, which in this case is 3. So it's going to go from 0, right, to 2, right, 0, 1, and 2, because we have 3 rows. So it'll loop through each of the rows, and then for each row I have a y value. And what I did is I said loop through all the y values, so from 0 up to 4. And the way I got that 4 was I said look in position 0 and tell me the length of that array, right? So if I were to draw this, it would look something like this. Okay, so I'm saying look here in position 0 and tell me how long is this array, and it's going to return the number 4, right? So my columns are going to go 0, 1, 2, and 3 because it's less than 4. And so what I'm going to say here is at my array in position x, right, and y. So the first time through it's going to be x is 0, y is 0. So at position 0, 0, put in the value of 0 plus 0, right? So in this box, put in a 0. And then what will happen is we'll reach the end of this loop. It'll iterate y up by 1. So now it's going to say is 1 less than 4? It is. So it's going to say in position 0, 1, right? So that's now this box. Oops. This box here, 0, 1. Put in 0 plus 1, which is the value of 1. And then y is going to go up to a 2, right? We get to the end of the loop, comes back, it says is 2 less than 4? It sure is. So position 0, 2, so this one, put in 0 plus 2, which is 2. And it'll iterate through. Once it gets to the end of that first row, then it'll come out here. X goes up by 1. Right? So instead of x being 0, x is now 1. It checks if 1 is less than 3. It is. And then it's going to set up a new loop for the y's. Right? So it's going to go position 1, because x is now 1, and y will be 0. And then y will be 1. And then y will be 2. And y will be 3. Right? And it'll keep stepping through. And then what I've done at the end here is I said, well, let's just display the contents of this two-dimensional array. And if I run that, what I've done is I created the exact same loop, right? So my display 2D method, my argument is that what I'm passing in is a two-dimensional array. So if I want to I have to tell the compiler I'm passing in a two-dimensional array. So one of the common mistakes here is people will say, oh, I'm passing in either a single-dimensional array or even just an integer. So make sure that you say that it's a two-dimensional array. And otherwise, I'm doing the exact same thing. I'm going to iterate across all of, I'm going to say for each row, go through every column and print whatever's stored in there and a space. So it's going to okay. So there's our 3 that was the first position of our single dimensional array. But then everything else you can see is really, it's an addition of the Cartesian coordinates, right? So at position 0, 0, we have a value of 0. At position 1, 1, that adds up to 2. At position 1, 2, we have 3, right? Because 1 plus 2 is 3. So that's a real simple, quick overview of how we can use, how we can define and use a multi-dimensional array. I hope that that helps in your understanding, and please don't hesitate to ask any questions in class.